Nuclear-powered submarines are capable of remaining submerged continuously for months. The only limitation to their underwater endurance is the supply of food for the crew. This is because food cannot be sourced. Underwater fish, for example, do not contain carbohydrates. Therefore, before departure, a large amount of food supplies is loaded onto the submarine. To resupply food in the middle of the ocean, helicopters or surface ships are used. So, what about the crew's oxygen needs? Where does the oxygen come from? Do submarines carry oxygen tanks, draw air from the surface through hoses, or use other methods? We'll explore that in this video. There are several ways to provide oxygen for the crew of a submarine, and there are differences in the methods used between conventional submarines, those powered by diesel-electric engines, and nuclear-powered submarines. In conventional submarines, oxygen is generally stored in pressurized tanks. Meanwhile, nuclear-powered submarines have the capability to produce oxygen while submerged underwater. How do submarines produce oxygen underwater? And why don't conventional submarines have onboard oxygen generation systems? Let's first discuss how nuclear submarines produce oxygen underwater. There are two methods: the primary method, which is always used, and a backup method for emergency situations. The first and main method is electrolysis. Electrolysis is a process of breaking down molecules using electric current. In this case, the molecule being separated is water. As we know, a water molecule consists of 2 hydrogen atoms and 1 oxygen atom. By splitting water molecules, oxygen can be obtained to meet the crew's needs. The raw material for electrolysis is seawater. To make the electrolysis process more efficient, electrolytes are added to increase the water's conductivity. One commonly used chemical is potassium hydroxide. By increasing conductivity, the electrical energy required for electrolysis is reduced. In the electrolysis process, water is placed in a container with 2 electrodes, a negative electrode cathode and a positive electrode anode. When electric current is applied, water molecules are split. Hydrogen gas forms at the cathode, while oxygen gas forms at the anode. A membrane separates the 2 electrodes to prevent the gases from reacting with each other. The oxygen gas is collected and pumped into a storage tank, and then distributed via pipes throughout the submarine's compartments. This ensures a continuous supply of oxygen for the crew. What happens to the hydrogen? Hydrogen gas is not needed on board and is expelled. This is generally not an issue during peacetime operations. However, in combat situations, this can be problematic because releasing gas creates bubbles that generate acoustic waves, which can be detected by enemy passive sonar. To address this, there are special methods for releasing hydrogen gas. These methods remain classified, but it is likely that hydrogen is chemically bound with certain compounds to form a liquid that can be expelled without creating bubbles. A similar technique is also used to remove carbon dioxide, which is exhaled by the crew. Accumulated carbon dioxide is dangerous and must be removed using a process called CO2 scrubbing. This involves soda-lime, a mixture of sodium hydroxide and calcium hydroxide, which chemically binds with carbon dioxide. Now, why are electrolysis systems commonly found only on nuclear submarines? Diesel-electric submarines typically don't have electrolysis equipment because they rely on batteries for underwater propulsion. The electrolysis process consumes a significant amount of electricity, which would drain the submarine's batteries rapidly. If a conventional submarine used electrolysis, its underwater endurance would be greatly reduced, as electricity would be divided between propulsion and oxygen production. Thus, conventional submarines must regularly surface to run their diesel engines and recharge their batteries. This opportunity is also used to take in fresh air and store it in pressurized tanks. Besides electrolysis, there is another method of producing oxygen on submarines: burning chlorate candles, also known as oxygen candles. These are cylindrical containers filled with sodium chlorate. The center of the cylinder is hollow and filled with iron powder. When ignited, the iron powder burns, forming iron oxide. The heat from this combustion triggers a thermal decomposition reaction of the sodium chlorate, which breaks down into sodium chloride and oxygen. The oxygen generated is then used to supply the crew in emergency situations, such as during a power outage or blackout. 1 kilogram of a chlorate candle can provide enough oxygen for one person for approximately 6.5 hours. That's how submarines meet the oxygen needs of their crew.